Well, I am G. Venkateshwara, lecturer in Electrical Engineering, Government Polytechnic, Massap Tank. Today's lesson is for third year diploma students in Electrical and Electronics Engineering, and topic is Power System 1 Generation. In this previous class, we are already studied about circuit breakers, that is minimum oil circuit breaker and bulk oil circuit breakers, their differences and also their comparison and also maintenance of the oil circuit breakers. Today's class is remaining circuit breakers, that is air blast circuit breakers and SF6, that means sulfur hexafluoride gas circuit breakers. So coming to air blast circuit breakers, in these circuit breakers, high pressure air blast is used to quench the air blast circuit breaker is used to quench the arc with the help of high pressure air. So in this way also we are classified air blast circuit breakers two types. One is axial blast circuit breakers, second one is cross jet air blast circuit breakers. In the axial blast circuit breakers, the air is applied axially to the arc. In the cross jet circuit breaker, in the cross blast jet circuit breakers, the air is applied at right angles to the arc. So first of all, we will see the axial blast circuit breakers, their construction, working. So first, as shown in the figure, air blast circuit breaker is like this, as shown in the figure. So this is the axial air blast circuit breaker. In the circuit breakers there is numbers 1, 2, 3, 4, 5. So first one is fixed contact. So this is the fixed contact. One is the fixed contact, and second one is the moving contact. This moving contact is connected to plunger, and the plunger is moving up and down in the plunger chamber. And third one is upper air valve for opening the moving contact from the fixed contact, and fourth one is the plunger, and fifth one is the low pressure chamber for closing the moving contact. So this is the constructionally, this is the axial blast circuit breaker. And coming to its working, under normal conditions, the fixed contact, that is 1, and moving contact, that is 2. So these two are enclosed, that means they are engaged in closed position by the special springs provided here. So these two, 1 and 2, that is fixed contact and moving contact, are fixed together and enclosed, held in closed position under normal conditions. Whenever a fault occurs on the system, then the protective relay action comes into picture. So in this way, the protective relay first operates the upper pressure valve, that is the upper pressure valve. It opens the third, that is upper pressure valve. It opens the, that means the protective relay first opens the upper pressure valve. In this way, the high pressure, that the pressure is at about 16 kgs per square centimeter, is applied upon the moving contact. So and it accelerate the moving contact into the, this is the chamber, that is the arcing chamber, into the arcing chamber. That means the pressure, the air is coming high pressure air comes upon the moving contact and accelerate the moving contact into the chamber, that is the arcing chamber and plunger chamber. So at the time there is a gap between the fixed contact and moving contact. Due to this gap, an arc is struck between the two contacts, and this arc is quenched by the high pressure air that is axially flows and surrounds the arc, so that the arc is quenched effectively in this type of circuit breakers. So this is the arc quenching of a circuit breaker. Then closing the, that means the moving contact is closed by the low pressure air valve. When we open the low pressure air valve, then the pressure applied on the plunger, and upon the plunger is goes upwards, and it will contact to the fixed contact, and the fixed and moving contact are held in closed position after the fault clearing. That means after once the fault is cleared, the moving and fixed contacts are held in closed position. In this way, in the axial blast circuit breakers working. So in this circuit breakers, how the arc is quenched? For this, in this circuit breakers, the arc is quenched mainly two types. One is cooling, that means high pressure air is applied on the arc, that is the cool air is compressed cool air is applied on the arc, that is one. And second one is sweeping away the ionized particles and replacing with unionized air particles. So in this way, here axial blast circuit breakers, the arc quenching is two types. One is cooling, other one is sweeping. So cooling increases the arc resistance, and also sweeping away the particles increases the dielectric strength of the medium between the contacts. So in this way, the arc is quenched effectively in the axial blast circuit breakers. Now coming to the cross jet axial blast circuit breakers. In this also, the construction is like this, shown in the figure. The construction is like this. In this circuit breakers, one is arc splitters, whereas in the previous circuit breakers, the arc splitters are not there, but here the arc splitters are there in this circuit breaker. Second one is moving contact, and third is the opening, that is the direction of opening, and fourth one is the compressed air flow. The compressed air flow is right angles to the arc. So this is the sixth one is the arc, this is the arc, and fifth one is the fixed contact. So this is the construction of the cross jet circuit breakers. In these breakers also, the working also like this. So in the working is like this. Under normal working conditions, the moving contact and the fixed contacts two are held in closed position under spring force. So there is a springs are there, but here the springs are not shown in the figure. There is a springs are due to that springs, the two contacts are held in closed position. So in this way, in the normal conditions, the current flows from the moving contact to fixed contact and to the apparatus. Whenever a fault occurs on the system, then what happens? The protective relay comes into picture. The protective relay operates and drags or pulls the moving contact. In this way, the pulling in the movement of the fixed contact is synchronized to the compressed air. That means there is a compressor is there in the circuit breaker, and the movement is synchronized with the opening of the compressed valve. So in this way, when the moving contact is moved some distance, then the gap between fixed and moving contacts occurs. Due to this gap, an arc is struck between two contacts. So the arc is struck between two contacts. At the same time, the valve is open, the air is rushed, that is 16 kg per square centimeter compressed air is rushed to the arc chamber, that is this is called exhaust chamber. So the air flow is like this, that is right angle to the arc, and this arc is taken away into the exhaust cylinder, and it is splitted away there because there is a splitters are there. So in this way, the arc is splitted in this chamber, and finally the arc is extinguished in the exhaust cylinder. So in this way, cross jet circuit breakers are working. So mainly the arc quenching in these circuit breakers is how many types? Three types. So one is cooling, second one is sweeping. So this cooling and sweeping are already in the axial blast circuit breakers, and third one is arc splitters. In the arc splitters, the arc is driven away into the exhaust cylinder. So the arc is splitted into small number of arcs. In this way also the arc resistance increases. These are all studied in the previous class. So in this way, in the cross-jet explosion, cross-jet circuit breakers, the arc is quenched mainly three ways. One is cooling, second one is sweeping, and third one is arc splitting. So both are arc splitting and cooling are increases the resistance of the arc, and sweeping increases the dielectric strength of the medium between the contacts. In this way the arc is quenched effectively in cross-jet explosion, cross-jet circuit breakers. So there are also in these circuit breakers there is also advantages and disadvantages are also there in this circuit breakers. So we will see the advantages of the circuit breakers. The advantages of the air blast circuit breakers are: first one is there is no risk of explosion and fire hazard. So in the oil circuit breakers there is a risk of fire and explosion. So these are eliminated in the air blast circuit breakers because the air is only the medium using the quenching the arc. And second point is it is suitable for frequent operation. So it is used for many suitable operation for frequent operation, whereas in the oil circuit breakers the oil is every operation the oil will be filtered or the dielectric strength of the oil is decreased, but in this air blast circuit breakers it will be used frequently, right. Next advantages are: third one is contact burning is less due to low arc energy. So in these circuit breakers the arc energy is very low, so therefore the contact burning is very less. And fourth point is it requires less maintenance. So oil circuit breakers requires maintenance regularly, but in these circuit breakers it requires less maintenance only. And fifth point is it gives high speed of operation. The speed of operation, that is the quenching time, arc quenching time is very less. So in these circuit breakers the speed of operation is very high compared to other circuit breakers. And there is also some disadvantages of the circuit breakers. Those are the disadvantages are like this. Disadvantages of air blast circuit breakers: a compressor plant is required for compressed air. So in these circuit breakers we are using compressed air at a pressure of 16 kg per square centimeter. So it needs a compressor plant. So in the circuit breakers a compressor plant is necessary. And second one is air leaks at pipeline fittings. In the circuit breakers air leaks at pipeline fittings because the high pressure air which flows into the pipes, so there is a leakage of air takes place. And other disadvantages are very sensitive to restriking voltage. So these circuit breakers are very sensitive to restriking voltage. And fourth one is current chopping. This current chopping means reducing the arc current level. Chopping is nothing but reducing the arc current level is called chopping. So current chopping is one of the problem in the air blast circuit breakers. So these are the disadvantages and advantages of the air blast circuit breakers and their applications, uses of the air blast circuit breakers. So there is the applications of air blast circuit breakers. Used from 12 kilovolts to 420 kilovolts. These can be used from 12 kilovolts to 420 kilovolts. So these are the normally used air blast circuit breakers. Next category circuit breakers are SF6 circuit breakers. SF6 means sulfur hexafluoride gas circuit breakers. So in these circuit breakers sulfur hexafluoride is used for quenching the arc. That's why these are called sulfur hexafluoride. fluoride gas circuit breakers, simply SF6 circuit breakers. Why these SF6 is used in the circuit breakers? Why these circuit breakers is, why the gas is used in these circuit breakers is because it has some properties, arc quenching properties. Those are the arc quenching properties of the SF6 gas are like this. Properties of SF6 gas. First one is dielectric strength is high. In these circuit breakers, the dielectric strength is very high. So one of the reason used for the dielectric strength is high. Second one is it captures electrons which are main responsible for arc maintenance. As already discussed, we are already discussed in the arc phenomena. In the arc phenomena, for maintenance of the arc is main responsibles are electrons. So these electrons are captured by this gas. That's why this gas we call as electronegativity gas. SF6 gas also called as electronegativity gas. That's why this gas captures the electrons which are main responsible for the maintenance of the arc. And other properties of the gas are it is an inert gas and hence non-reactive to the components of CB. So it is an inert gas and hence non-reactive to the components of the circuit breakers. So this means we can use less clearances between the parts of the circuit breakers, so that the compact size may be achieved in the circuit breakers. And fourth point is thermal conductivity is high. Thermal conductivity is the thermal conductivity is useful in cooling the arc. So in this way, in this type of circuit breakers, SF6 is used. So these are the some of the properties of the SF6 gas, and construction and working of the SF6 gas are like this. So constructionally, SF6 gas circuit breakers are divided into, one is interrupter unit, second one is gas unit. So first one is interrupted unit. So as shown in the figure, the interrupted unit is like this. So this is a interrupted unit in the SF6 circuit breakers. So one is the moving contact crossbar. So this is the moving contact. So for fixed holding, these are the holding. This means the moving contact crossbar, holding crossbar this is. And second one is current carrying fingers of moving contact. These are fingers. So these fingers are related to the moving contact. So these are current carrying fingers of the moving contact. And third one is orifice. Orifice means it is pipe which to and fro, the movement of the moving contact to and fro is in this orifice takes place. So this is third one is the orifice, and fourth one is the nozzle. This nozzle we call as interrupted nozzle. The nozzles are closely to the two contacts, that is the moving contact, and fifth one is the fixed contact, and these are also, there is also a fingers, current carrying fingers are this. These are related to the fixed contact. So these nozzles are placed around the two contacts, that is fixed and moving contacts. And sixth one is the interrupted chamber. Sixth one is the interrupted chamber. So this is the interrupted chamber of the SF6 gas circuit breakers. So next one is gas unit. The gas unit is like this, as shown in the figure. The gas unit is like this. So first one is, these are filters. These are filters. Second one is high pressure reservoir, that is stored gas. The gas, SF6 gas is stored in this reservoir at high pressure. And third one is service connection. This is the service connection. And fourth one is the relief valve. and fifth one also filter, sixth one is the compressor, seventh one is the low pressure alarm, eighth one is the high pressure alarm, ninth one is the low pressure lockout, 10th one is the low temperature alarm. So 11th one is the LP system, that is the low pressure system. 12th one is the high pressure system, and 13 also a low pressure alarm, and 14 is a heater. The heater is placed inside the reservoir because the heater is provided with a thermostat. The heater is provided here with a thermostat. The thermostat is set at a 16 degrees centigrade to prevent the liquidification of the gas. So below this temperature the gas is liquefied. So that's why in the reservoir chamber, the gas in the reservoir chamber a heater is provided, and the heater is set at a 16 degree centigrade. So in this system the low pressure system is there and high pressure system is there, and connected compressor is there and reservoir is there. So these are all the gas unit. Whenever under next coming to its working, whenever under normal working conditions, the figure is under normal working conditions, the moving contact and fixed contact are held in closed position by spring pressure or by inserting the fingers one in another. That means there is a fingers and there is also fingers. Due to these fingers are inserted one into one. So these two, that is the moving contact and fixed contacts, are held in closed position in the normal operating conditions, and also the gas, that is the SF6 gas, is surrounded by the two contacts at a pressure of 2.8 kgs per square centimeter in the normal operating conditions. So whenever a short circuit or abnormal conditions occurs, then the relay comes into picture. The relay which operates the high pressure valve. So in this way, that means the moving contact, here the moving contact movement is synchronized to the opening of the high pressure valve. So at the same time the high pressure valve is opened, and at the same time the moving contact is withdrawn, and a gap between the fixed contact and moving contact is there. Due to this gap, an arc is struck between these two contacts. At the same time the high pressure, that is the pressure at about 14 kgs per square centimeter gas, that is SF6 gas, enters into the interrupting nozzles and applies on the arc. At the same time the arc is quenched because the high pressure SF6 gas which captures the electrons of the arc. So the gas which captures the electrons of the arc, then what happens, here is a quickly builds up high dielectric strength between the gaps. So the dielectric strength which can prevent the restriking voltage, therefore the arc is quenched effectively in these circuit breakers. Then the collected gas in the chamber is collected by the low pressure chamber, that is we are already seen the low pressure chamber. So the gas is collected by the low pressure chamber. After clearing the fault, the moving contact is moved to the fixed contact and fixed by the set of nozzles, and also high pressure valve is also closed by the spring force, and it is all working and automatically. So this is the quenching or working of a SF6 circuit breakers. So this is the working of a SF6 circuit breakers, and it has also some advantages and disadvantages. So first we see the advantages of the SF6 gas circuit breakers. Those are like this. Advantages of SF6 gas circuit breakers: current chopping is minimum. So this is the main problem in the air blast circuit breaker, that is the current chopping is a problem in the air blast circuit breakers, but that problem is minimized in the SF6 gas circuit breakers. That's why current chopping is minimum. That means the arc current level is reduced very much in the SF6 gas circuit breakers, that is the current chopping. Second one is closed circuit gas cycle reduces the moisture problem. So the gas unity, the entire gas unit is a closed cycle. So therefore there is no moisture problem in this circuit breakers, because the moisture which gets on circuit breakers, the electrical properties are decreased, reduced. That's why there is no moisture in the circuit breaker. Moisture problem is there in the circuit breakers. Next advantages are, it gives noiseless operation. It gives smooth operation. It gives noiseless operation. And fourth one is, due to high dielectric strength, electric clearances are reduced much. So the electrical clearances are reduced very much. That why we can make it a compact size. That means the size of the circuit breaker can be reduced due to the high dielectric strength of the gas. And other advantages are like this. Fifth one is, arcing time is small. Arcing time is small, and hence contact erosion is less. So the contact erosion is depend upon the time of arcing. The time of arcing is increased, arcing erosion takes place, but the time of arcing is less, the contact erosion is less. Next, sixth one is, no reduction in dielectric strength due to carbon formation. No reduction in dielectric strength due to no carbon formation. So in the oil circuit breakers there is a carbon formation is there, but in this circuit breakers there is no carbon formation. So therefore there is no reduction in the dielectric strength of the gas. So these are the some of the advantages of the SF6 gas circuit breakers, and there is also some disadvantages. Those are, first one is disadvantage of SF6 gas circuit breaker. Costly, due to high cost of SF6 gas. So SF6 gas is very high cost, therefore the circuit breaker is costly. That is the first disadvantage. Next disadvantages are, required additional equipment for recondition of SF6 gas after every operation. So recondition of the SF6 gas, should be done every operation. So every operation the gas should be reconditioned. That is the one disadvantage. And coming to applications of the or uses of the SF6 circuit breakers are, application of the SF6 circuit breakers are like this. Applications of SF6 gas circuit breakers used from 72.5 kilovolts to 760 kilovolts. So these can be used from 72.5 kilovolts to 760 kilovolts because of their high cost. So these are used for only for high voltage systems only these are used. So these are the some of the disadvantage and advantage and applications of the SF6 circuit breakers. SF6 circuit breakers. So these are the some of the circuit breakers were discussed. That is, first one is air blast oil circuit breakers, minimum oil circuit breakers, bulk oil circuit breakers, and air blast circuit breakers, and lastly SF6 circuit breakers. And next one is protective relays. We are going to study about the protective relays also. So in the power system, why a protective relay is needed? In the protective system, why a protective relay needs? So in electrical power system, it consists of transformers, alternators, transmission lines and distribution lines, and also associated equipment. So abnormal conditions and short circuits are normally occur on the power system, often occur on the power system. Due to these we call as faults. This we are called these conditions as faults. So these faults apply on the power system. What happens? A high current flows. we allow this high current in the apparatus of electrical apparatus, what happens? They will damage. So to protect these apparatus from these abnormal and short circuit conditions, we require a protective system which needs a protective relay. So in this way, the protective relay initiates the faulty system, initiates the opening of the faulty system from the LC system, from the healthy system along with the circuit breaker. So therefore, the faulty system is disconnected from the healthy system with the help of protective relay. That is why we need a protective relay. So how it works? The protective relay, how it works? You see in the figure, as shown in the figure, the protective relay figure is like this. So first one is battery. The battery is connected, first one, and this is a trip circuit 2. Number 2 is the trip circuit. Third one is relay contacts. So these are the relay contacts. Fourth one is the relay coil. Fifth one is the that element protected, that means this is the line. So this line here, it is connected with electrical equipment, so that electrical equipment is protected. So this is the protected element, that is the fifth one is the protected element. Sixth one is the current transformer, CT is simply called as C.T. CT means current transformer. And seventh one is the solenoid. Solenoid is nothing but a coil. We may call a coil as a solenoid, and in this solenoid an iron plunger core is there. This is the iron plunger core which moves into this coil, that is solenoid. And eighth one is the CB. CB means circuit breaker. So in this position, here you see the circuit breaker is opened and relay contacts are closed. This is normally occurred when a fault occurs. So this situation is when a fault occurs, this will like this. If otherwise under normal conditions, the conditions is like this. The circuit breaker is normally closed to these contacts, but this relay contacts are open under normal conditions. Whenever a abnormal conditions occurs, what happens? Very high current flows in this element, that is in this line. Due to this current, the current transformer current also increases. This current increases in this coil also, and this coil operates and touches or contacts will be closed here. Here normally the contacts are open, but here you see it is contacted, but normally these contacts are open. Due to the high current flowing in this coil, the contacts are closed. Due to closing of these contacts, what happens? There is a closed circuit. When the contacts are closed, there is a closed circuit. Therefore, what happens? The current flows in the coil, that is the solenoid. Due to the flowing of the current in this solenoid, the magnetic field of this solenoid is to pull the iron plunger inside into the solenoid, to pull the iron plunger core inside the solenoid due to the current flowing in the solenoid, that is coil. Due to what happened? The contacts of the circuit breakers are open. So like this, the contacts of the circuit breakers are open. Therefore, the system, that is the apparatus, is disconnected, that is the healthy system is disconnected from the faulty system. So this is, there is a fault. So this is the faulty system. The faulty system or the faulty part is disconnected from the healthy part using a circuit breaker in conjunction with relay. So the relay is operate like this in the protective relay. So this is the normally the relay operation. So what are the requirements of a good relay? That means for satisfactory operation of the relay, what are the requirements to be needed for a relay? The requirements of a relay are like this. The requirements are, first one is selectivity, speed, sensitivity, reliability, simplicity. So these are the requirements of the relay. So what is a selectivity? Here selectivity means the protective relay system, the ability of the protective relay system that it operates to select correctly faulty system and disconnect that faulty system from healthy system. That means it will detect correctly faulty system and also disconnect the faulty system from the healthy system. So in this way, that is the selectivity of a relay. Next one is speed. So the relay is, this means speed. The relay operation is as fast as possible. That means the relay is acted very fast. If it will not acted fastly, what happens? Due to short circuit, very high current flows through the apparatus of the electrical apparatus. Due to this very high current, what happens? They will damage. So the relay also, it will act very fast. That is the speed. Next, third one is sensitivity. So what is the sensitivity? Here it is the ability of the protective relay system that it will operate with low values of activating quantity. Here activating quantity means the activating quantity is a current or voltage or power. So whatever it may be, it will operate low values of the operating quantity or activating quantity. That means the selectivity is directly related to the input of the relay. That means volt amperes of the relay. If the volt amperes are less, the selectivity is sensitivity is more. That means the input to relay is very less, then sensitivity is very more. So that's why the input volt amperes also called as burden of the relay. We also call it as burden of the relay. Fourth one is reliability. What is the reliability? Here reliability means the relay that it should operate under predetermined or specified value. That means we set a relay particular value that it should operate to that particular value only. That means predetermined value, that it should operate under the predetermined value. That is the reliability. Next one is simplicity. And what is simplicity? Here the simpler the protective system, then its maintenance is very easy. So it is simple, the maintenance also very easy. And here also reliability and simplicity are closely related. The simpler the system, then higher the reliability of the protective relay. So these are the requirements of a protective relay. Next, coming to types of relays. Then types of relays. What are the types of relays? The types of relays are classified upon three types. First one is according to application or duty. Second one is according to time of operation. Third one is according to construction and principle. So let us see first application or duty. Protective relays are classified according to duty or application. So first one is over voltage or over current or over power relay. So types of relays according to duty or application. We will classify these are 6 types. So first one is over voltage or over current or over power relay. So in this relay, the relay operates when the voltage or current or power rises above the specified or predetermined value. So it will operate only when the particular voltage or particular current or particular voltage rises the predetermined value, then only it will operate. So these are called over voltage or over power or over current relays. Next, second one is under voltage or under current or under power relay. So in these relays, the relay operates whenever the voltage or current or power falls below a predetermined value. So in the previous one rises above predetermined value. In this case, it will falls below predetermined value, then only the relay should operate. And third one is directional or reverse current relay. So in this in this relay the relay operation takes place, that is the current that is the relay operation is sensibly independent of the magnitude of the current or activating quantity. So that is the relay operation is depends upon the sensibly independent of the magnitude of the current or activating quantity, like that the relay operates. And next, coming to other types of relays are reverse power or directional relay. In this also the relay both voltage and current both are assumes a specified phase displacement with respect to power. That means the relay operates when the both voltage and current specifies a phase displacement with respect to power, then only the relay operates. And fifth one is differential relay. In the differential relay, the differential relay is operation like this: when two or more activating quantities, that is the difference between two or more activating quantities, that it may be magnitude or it may be phase, that means phase difference or magnitude difference between two or more activating quantities then occur, then the relay will operate. So this is the differential relay. And sixth one is the distance relay. So the relay operation, the sixth one is distance relay. The distance relay operation is like this: it depends upon the ratio of the voltage to current, that is V by I ratio. That is V by I ratio is nothing but impedance. The impedance is nothing but Z. So these relays are also called impedance relays or distance relays. So these are the types of relays according to their duty or application of the relays. Next types of relays are according to construction and principle of operation. According to construction and principle of operation, first one is electromagnetic attraction relay. So these are further divided into attracted armature relay, and second one is solenoid relay. So in this attracted armature relay, the relay operation depends upon the attractive force offered by the magnetic field due to current flowing in the relay coil. That is the current flowing in the relay coil is set up a magnetic field, and this magnetic field is attracted the relay apparatus. So in this way the electromagnetic relays are operated. Next, second one is electromagnetic induction relay. Electromagnetic induction relay is, it is the relay operation depends upon the rotation of the disc between two electromagnets. That is the disc operation depends upon the interaction of the magnetic fields set up by the induced currents and alternating magnetic fields. So due to these fields the disc is rotated. Like this the relay operation is depends. And third one is electric dynamic relay. In this also a moving coil is there. The moving coil is freely rotate in the magnetic field, that is the electromagnetic field. And fourth one is the moving coil relay. In this also a moving coil is moving in the permanent magnet of the moving system. So the moving coil is moved in the air gap of the permanent magnet. And thermal relay, the thermal relay operation depends upon the heat produced in the element of the thermal relay. So the thermal relay operation is like this. So these are the some of the types of the relays. In the next coming session we will study about the remaining relays. So right.